Okay, welcome everybody. Go ahead and take a seat, please, and everybody go ahead and get out your whiteboards, please. While I go over the objectives, I would like for you guys to all please write for me, just a short sentence, what the carbon cycle is. Okay? Hold those up when you're done. While you guys are doing that, I'm going to go over the day's objectives. Today, students will be able to identify organic and inorganic matter involved in the carbon cycle, interpret how the flow of carbon would occur between related items in the carbon cycle, and construct a flow chart showing that you understand those relations in the carbon cycle. Okay, go ahead and hold those up when you guys are ready. Okay. Who wants to go ahead and read their answer for me? Julia, what did you put? Okay, so Julia said that the carbon cycle is how carbon moves between plants and animals. Okay, great. Yeah, that's definitely one part of the carbon cycle. That's great, because we haven't really talked about it that much. Okay. One other person, go ahead and give me a response. John, what did you put? You put the carbon cycle is when volcanoes erupt. Okay, that's awesome. You saw it right on the board. That's also part of the carbon cycle, though. That's good. Okay, guys, we're going to move on now. Just going to do a quick lecture. Don't worry, it's not going to be too long. If I could have somebody please come up to the front and hand out the little, you guys, we've done this before, kind of a note-taking handout that I have for you guys, so please, thank you. Handout for that, and you guys can write in the pertinent information as I go along. The notes will be up on the board as well. So I know, guys, we've sort of been talking about, or started a new unit, I guess, this week, concerning evolution, right? The first thing I want to talk about today, we're going to be talking about carbon today and probably the rest of the week as it sort of relates here. First of all, what is carbon? John, yeah. Carbon's an element, right? It's got an atomic number of 6, as you can see on the board, and the most stable isotope, 6 protons and 6 neutrons. Okay, there are other isotopes too, and actually we probably will talk about those stuff a little bit later as it relates to dating, which is a really big idea in geology concerning our timeline of evolution. Carbon is really important not only for geologic and non-biotic activities, but it's also really, really important in biology, right? Every single living organism that we know of, in fact, has carbon inside of it. Carbon's also really important as CO2, one of the most important gases in our atmosphere. We'll talk about that a little bit more here coming up. But without CO2 gas, life would be very, very different on Earth. So I know what you're saying. This isn't chemistry, and it's not biology, right? We're in an earth science course. Well, the cool thing about earth science is that it sort of incorporates every other type of science there is out there. Chemistry, biology, physics. And then there's a lot of sort of more specific avenues. Paleontology is sort of within the broader earth science, but with a specific scope. And a lot of what we know about evolution comes from paleontology, which is sort of the study of the remains of past life forms. So as I mentioned earlier, CO2 is a greenhouse gas, and we sort of talked about what that means. Who can tell me what a greenhouse gas is? Michael. Right, so a greenhouse gas is a gas that traps heat within the Earth's atmosphere as it tries to escape, thus warming the environment around us. Without greenhouse gases, especially early in Earth history, when the sun was not as powerful as it is now, life would have taken a very different course. In fact, might not have even been able to begin. Excuse me. That being said, however, it probably wasn't carbon dioxide that was the initial greenhouse gas that allowed the planet to warm enough for there to be liquid water, and therefore evolution sort of as we know it. But after sort of plants started photosynthesizing, there was free oxygen in the atmosphere, which combined with carbon in the earth and formed CO2 gas, which is really important, as you guys will see sort of going forward. So as I already mentioned, carbon exists in all living forms, and as we've discussed, a lot of inorganic forms. Carbonate rocks, we've looked at limestone, dolomite, in some of our labs that you guys should be familiar with. Those are big time important parts of the carbon cycle. So speaking of the carbon cycle, here's a quick diagram of it. We sort of talked about it here as you guys walked in the door. And so both of you guys were right in that it is how carbon goes from plants to animals to the atmosphere. It is the process of volcanic eruptions emitting CO2 gas into the atmosphere. That gas will mix with water, create carbonic acid, go back into the earth. So in fact, the carbon cycle is sort of a combination of all of those things. It's all of the matter that has carbon inside of it, and then all of the processes by which it's transferred from one organism into another. And you guys remember we've talked about the biosphere, the hydrosphere, and the geosphere, right? So animal life, water, and the planet itself. And carbon is involved in all three of those greater spheres. So where do we see carbon fitting in our broader scope of evolution that I was talking about? Well, as I mentioned, all life forms contain carbon. So without it, at least life that we know it now wouldn't even exist. You guys should have had probably some life science by now, and they've probably told you all about proteins and carbohydrates, both of which form long chains that have carbon. Aquatic life, which is where life started on planet Earth in the ocean, and they've long used calcium carbonate to precipitate shells. Without carbon, that wouldn't be possible. Oh, interestingly, calcium carbonate is what forms a lot of the limestone that we see around here and throughout the world, if you guys remember from our lab a couple weeks ago when we talked about that. So some of the earliest life forms, well, they were definitely photosynthetic. And so what happened was, after those life forms evolved, they were respiring oxygen. And that changed the basic makeup of our atmosphere because there was free molecular oxygen, which allowed for really bigger evolutionary change that we'll talk more about. So as I mentioned earlier, also without CO2, Earth probably wouldn't have been warm enough to support large mammal life, like you and I, right? So yeah, I don't want to talk about it for too much today. I'm going to go ahead and get you guys involved in an activity. So what you're going to do is create your own flowchart. We've done these before, sort of smaller scale. You'll remember the rock cycle that we did. We had the flowchart, igneous, metamorphic, sedimentary, arrows going back and forth between the various types of rocks. You're going to do something very similar to that today. We're going to use, if you want to, you don't have to, but the simplemapper.org website that we used in the past to create this flowchart. I like using that because I'm a really bad writer, but if you prefer, you can do this on a piece of paper and just hand it in to me that way too. That's totally fine. What I want you guys to do is come up with at least 7, it's this many, organic or inorganic matter that you think would be involved in the carbon cycle. Try to have at least a couple of them in there that are organic, because this is sort of, we're talking about it in the construct of evolutionary biology here a little bit too. So, and I really want you to think about how life fits in all of these arrows that you're going to be drawing, right? So you're going to have 7 different bubbles minimum. You can do more, that's fine. They can be broad, they can be specific, okay? But just make sure you know you have to have 7 of them. And then I want you to have all of the arrows that you can think of that would connect all of those bubbles. And then on those arrows, I want you to write at least one word, some sort of a verb, describing the flow of carbon between those 2 examples of matter. Okay, so go grab yourself a computer. Oh, one other thing, sorry. If you guys finish this, you have the rest of class. But if you finish it before the end of class, I have some computers set up also in the back. And back there's a really cool YouTube video that I have them ready to go on that's going to talk about Snowball Earth, which is a really cool time in Earth history during the Precambrian. If you guys remember the geologic timescale that we've worked on throughout the year. And that's kind of where we're going to go a little bit next, because it has a lot of implications for geology, for evolution. So that's ready to go if you guys finish this. Otherwise, I'll put up the code for you to merge your map to mine on the Simple Mapper. Or again, you can do it on a piece of paper, that's fine. Those of you who work with Miss Johnson, you know who you are, please come on up to me. For my students on IEPs, I've got sort of a word map and kind of already started them off there. Okay, so there's that. Let's see. Okay guys, you should be just about wrapping up right now. Quick review here. Here I started off my own carbon cycle. Why don't I have a couple of you guys tell me what are a couple of things that you put on your web, and I'll add them to mine. Okay, Julia, go ahead. That's not working. Okay, great. So you said that you had one from the atmosphere to plants. Oops. From atmosphere to plants. And what was your verb connecting the two? Photosynthesis. Cool. You guys agree with Julia? Yeah, that's a good one, right? Awesome. So that'll pop up. Let's get one more that I didn't have up there already. Okay. So I heard somebody say from humans to the atmosphere. That's a good one too. Humans. If I can get this to work. Humans. And what was your relation? Respire. Okay, cool. Respire. To the atmosphere. So the cool thing about doing it on this thing, if you're like me and you have terrible handwriting, it just pops it up for you to check out down here. Let's go to full screen. And, oh, yep, misspelled atmosphere. Okay. Edit. Atmosphere, no, that's right. Atmosphere. Atmosphere in humans, that's the one that I messed up. Okay, well, I can't find it on there, but you guys see what we did. Okay, get out your whiteboards one more time for me. And I want you to put up one relation on the whiteboard that you have that we haven't talked about on here, okay? And show that to me. And then you guys are out of here. Thank you.